In this quick review, we want to discuss the general addition rule for probability. And the formula for this is the following. If you have any two events, E and F, so we have these two events, all right, and we'll do some examples to show you what I mean by these two events. If I ask you or you're asked, what is the probability that event E or event F happens? Well, the formula for that is just the following. It's equal to the probability of the first event E plus the probability of the second event F. Now, if these two events have a common outcome, then you would subtract the probability that both E and F occur. Now, if the events are disjoint, meaning there is no common outcome, this probability will equal 0. All right, let's work some examples here using this formula. So here's a problem. Suppose you flip a coin and then roll a die and you record your results. All right, so my question is this. What is the probability of flipping heads or rolling a 6? Let's just start by writing the sample space for this, just so you can see. So we're going to flip a coin and then roll a die. So you could flip heads, roll a 1, heads, roll a 2. This is how I'm going to write the outcomes. Heads 3, heads 4, heads 5, and then heads 6. Or you could get a tail, then a 1, tail, then a 2, tail, then a 3, tail, then a 4, tail, then a 5, and then a tail, then a 6. So there's 12 outcomes to this. So look, just so you can see here, and I'm going to show you the formula works this way. Probably of flipping heads or a 6. Well, logically, these 6 outcomes are a head or a 6. And then a T6 or a tail, then a 6. Well, that is still a tail, that is still a head or a 6. So this probability should be 7/12. Well, let's use the formula here. It's probability that event E or F happens. This is the probability that E happens plus the probability that F happens minus the probability that E and F happen. And look, you're going to need this one because there is a common outcome between flipping heads or rolling a 6. It's getting an H6 right here, H and a 6. All right, so the question is this. What's probably you flip heads or you roll a 6? Well, just using the formula. Head is my E. So this is the probability you flip heads on a coin. Plus F is a 6, probability you roll a 6. Minus the probability you get a head and a 6. Well, don't overthink this. When you flip a coin, what's probability to get heads? It's 1/2. When you roll a 6-sided die, what's probability 6 comes up? Well, that's 1 out of 6. Now look here. If you flip a coin and then roll a die, what is the probability to get a head and a 6? Well, there's only one outcome that's a head and a 6, and there's 12 total outcomes. Common denominator here, this is 6/12 plus 2/12 minus 1/12. They all have the common denominator of 12. So 6 plus 2 minus 1 gets me 7/12. So this formula works. All right, let's do one more quick example talking about drawing cards from a deck of cards. All right, so first off, what's in a standard deck of cards, just so we're clear? There's 52 total cards. There's the clubs, the spades, the hearts, and the diamonds. And then there are 4 suits. And then each suit contains the same 13 cards. An ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, then a jack, a queen, and a king. Okay? All right, so here's the problem. If you draw a single card at random from a deck of cards, so imagine shuffling up the deck and then drawing one card. The first question is, what's the probability it's a queen or a king? So that tells me that or right there tells me it's going to be the general addition rule. So I'm going to take what's probability I get a queen from a deck plus the probability of a king just going back to our formula, it's probability of the first event plus probability of the second event minus the probability, this is weird, that both of these things happen. Minus the probability that that card I draw is both a queen and a king. That sounds weird. Well, look, how many total cards are there in a deck? There's 52. And how many queens are there? 4, one in each suit. How many kings are there? 4 kings out of 52 total cards. Now, look, this is an example of events that are disjoint, meaning they cannot happen together. Okay. Can I draw a single card, and have it be both a queen and a king? No. So that probability is 0 out of 52. So 4 plus 4 is 8 out of 52. Or this can very simplify to 2 out of 13. But now let me ask you this question. What's the probability you get a queen or a spade from the deck of cards? So let me ask you this. Can you get a card that is both a queen and a spade? Yes, it's right here, the queen of spades. So you got to take that into account when you compute this probability. So the or statement here, or here tells me, the or right here tells me it's going to be the general addition rule. So I want the probability of a queen plus the probability the card you draw is a spade minus the probability the card is a queen and a spade. Well, look how many queens are in a deck. 4. How many spades are there? 13. Now, here's the thing. If you didn't include this last part here, there are 4 queens, including the queen of spades. There's 13 spades, including this queen of spades. So you would have double counted the queen of spades. So now how many cards are both a queen and a spade? Just 1, the queen of spades. So minus 1 over 52. So 4 plus 13 is 17 minus 1. That gets me 16 out of 52. Or this would simplify to 4 out of 13. Okay, I hope this quick review was helpful with this general addition rule. As always, if you need additional help, please reach out to your instructor.